Okay, so let's discuss the next service we have here that can be used for the asynchronous communication. That is AWS SNS, that is simple notification service. So this works on a very simple logic. That is here. First, we need to create a simple topic. So topic is like creating your own channel on YouTube. Okay. So let's say you have created your own channel on YouTube, and once you have created, then the users will have an option to subscribe, right? So all those users who will subscribe to your channel will get the notifications, right? If you upload a video or if you upload any post on your YouTube channel, all the users will get notified, right? So the exactly same concept is applied over here. So here first we will create a topic. We'll not create a channel, but here we will create a topic. So you can consider a topic like a channel on YouTube. So that topic can be subscribed by different services. So these services are like users who are going to get the updates from this topic. Okay. So that's a simple concept here. We will be creating a topic, and that topic will be subscribed by the different services. Now let's look at a simple demo of this. So that will help you to get a complete idea of how the SNS is used and how it fits in the architecture. And then we will discuss a brief details about the SNS. And then finally, we will look at a real life example where this can be used. Okay. So here to understand the demo, first of all, here we will have a client. So client is nothing but from where we will initialize the request. Then we will have a service A, that's a simple Spring Boot application that is going to receive that request. And that request or that message we will send it to the SNS topic. Okay. So now that topic will be subscribed by one of the queue. Okay. So here this can be subscribed by multiple such type of queues or any other services like Lambda or any other microservice. But here we'll use SQS, that is which we already discussed, simple queue service. Okay. So this will be subscribed to that. So once the message has been pushed to this SNS, the SNS will push that message to all the subscribers, and here one of the subscriber will be SQS, and from this SQS we will consume that message in another service B. Okay, so that's the overall flow. So let's look at this demo, and we'll understand how this is worked. So first let's create a topic in simple notification service on AWS. So for that I have already logged into AWS console. So here search for SNS, simple notification service. So here right now I do not have any topic, so let's create a topic. So while creating a topic, we have multiple configurations to configure. So first of all, here what kind of output we want from this topic. So if we select for first in first out, then it will be like whatever the messages that will be pushing from the service, that will be pushed out to the subscribers in the same order. But if we go with the standard, then the ordering will not be maintained, but it will make sure that at least once the messages are delivered. Okay. So here let's go with the standard option, and here let's give a name to this topic. So let's say SNS demo topic. So we'll give this name to this topic. Next, display name, we do not need to give any display name right now. So for the encryption, what does this option suggest here? So whatever the messages that will be sent from service A to the topic, that will be automatically encrypted. So SNS will make sure the TLS is established between both the services, and over the TLS the message will be sent so that it gets encrypted. But now why we have this option? So this option will make sure that once the message has arrived, okay, let's say we have a message. So this message has arrived over here. So for the moment when the message is present in this SNS topic, do we want to keep it encrypted or just as a normal message? So that's the option they are giving over here. So if we enable this option, then what this will do, once the message has arrived from any service inside the topic, so the message will get encrypted. We will not be able to read it or normally, right? So right now we do not need that. So that's the reason I'm keeping it disabled. But whatever the message sent over the network, that will be automatically encrypted. Okay. Next, coming to the access policy. So here access policy, as we also discussed in SQS, similarly we have over here. So here there are two things. First of all, regarding the publisher. So who can send the messages to this topic? So that's we have multiple options. The first one, only the topic owner. That means whoever have created this topic, that whoever having the access to this AWS account, so having those credentials, that user can able to send the message. If we make it as everyone, then anybody on the internet can send this the messages to this topic. So this can be done if we have a public API or when we want to give access publicly, but that's not a secure or a ideal selection because that can lead to multiple attacks. So and the final one, we have only the specified AWS account. So if we go with this, then we have to mention the another AWS account to which we want to give the access. So here we'll be going with only the topic owner. That's regarding the publisher who can send the message. Now coming to the subscriber, who can subscribe to this topic, like who can have access to these messages. So again, here we have multiple options. If we make it as only the topic owner, that means only the services that are present within this AWS account will be able to receive or subscribe to this topic. Next, if you make it as everyone, then any AWS account can subscribe to the topic. Then if we go with only specified AWS account, then we can just give access to one of the AWS account that we want to give. Then only requester with certain endpoints. So if you go with this, then we have to mention a couple of endpoints that will have access to this topic or that can subscribe to this topic. So for this time being, or for this demo, we'll go with only the topic owner. So this will help the other services also within this AWS account can able to subscribe. Okay. So next, here also you can go with advanced access policy, where if you want more granular access policy, then we can go with advanced option. Next, here we have data protection policy. So this policy defines which sensitive data to monitor to prevent from being exchanged via our topic. So this can be configured, but for now we can go with the basic configuration. Next, we have the delivery policy. So how we want the messages to be delivered. The policy defines how Amazon SNS retries failed deliveries to HTTPS endpoints. Okay. So right now we are not configuring any HTTPS endpoints. So here we'll ignore this configuration. Then message delivery status logging. So this is regarding the logging of the message delivery status. So we'll just keep it as default, tags as default, and active tracing also as default. So this will use AWS X-ray service for active tracing of the topics to view its traces and service map in Amazon CloudWatch. Okay, so this will incur the additional cost, but for this demo we do not need this. So I'll just keep everything else as default. So just need to mention the topic name. That should be enough. Then let's create the topic. So we have successfully created the topic. Now, according to our architecture, next we need a SQS queue that will subscribe to this topic, right? So for that, let's create a new queue. Okay, so here we can search for SQS, simple queue service, create a queue. Let's go with the standard queue, and let's go with demo queue. Then let's keep everything else as default. We already discussed these settings in the previous video. Then for the encryption, again here it applies the same logic. The transit encryption is already enabled, but if you want the messages to be encrypted when in the queue, then we need to enable over here. So it is already enabled, so let's keep it as whatever it is default. Access policy also default. Then here we do not need a deleter queue for this demo, so we'll just keep everything as default. Then let's create the queue. Okay, so the queue is created and our topic is also created. Now let's create the subscription. So here we need to create the subscription. For that, we can just click on create subscription, and here we need to select which service we want this to get subscribed. So here these are the only options that can subscribe to the topic of AWS SNS. So here it can be SQS, AWS Lambda, email JSON, HTTPS, or SMS. So all these are the different services that can subscribe to this topic. So for our demo, we are using SQS. So here let's select the AWS SQS. So here we need to provide the ARN. So we'll get the ARN from here. Next, we'll just paste it over here. Okay. Next, we need to, let's keep everything as default. We will not change anything else here. Then let's create the subscription. Okay, so we have successfully subscribed to this topic. Now what will happen? The moment this topic will receive a message, it will just publish that message to all the subscribers, and among them this is a one subscriber, and this queue will get the message, and this queue will be polled by one of the microservice, and that microservice will be able to get that message. Okay, so now let's configure these two services. So for this demo, I'll be using one single service that will be acting as both service A and service B. So let me just do that. For that, I'll need a couple of things that need to be configured. First of all, we need to add a dependency in the pom.xml. So that is, first of all, here we have added the web dependency that are needed for a Spring Boot application. Then AWS starter SQS for the SQS service. Then for SNS service, we need to add this dependency. Okay, that's all. With these two dependencies should be sufficient to make sure this application is acting as both client and server. That means here it will act as both service A and service B. Okay, so let me just explain you the flow here. So for SNS configuration, before that we need to add some few configurations over here. So to receive the message from the queue, we need to add the endpoint. So for that, grab the endpoint from here. Okay, just replace this. Okay, next we also need to get the topic ARN so that this service will be able to publish the message to this topic, right? So for that, get the ARN of this. So this is the ARN of this topic. So let's paste that. Okay. So next we also need the access key and secret key for a user having the access to both of the services. So for that reason, you need to create a user with this having both of these access. So for that, you need to go to IAM. I already discussed this in the previous video for SQS. So let's do the same for another user. So go to user, create a user. So you can just name a user as SNS SQS user. So we'll just attach the policy directly. So you search for SQS full access, SNS full access. Okay. Next. Okay, just create the user. Okay, so we need to change the name. Let me go back and give some other name. SNS SQS user 2. Okay, so the user has been created. So go to this user and create the access key. So here we'll be using application running outside AWS. Next, create access key. So access key and secret key are here. Just copy this access key and secret key and paste it over here. And that's it. This application will be able to access SNS and SQS. Okay, so that's regarding the configuration. Now coming back to the application part. So here, first of all, I have created a bean that will get instantiated when the application starts. So this bean will help me to connect this application with the SNS. Okay, so this here I had this code that will grab the credentials and the region in which this SNS is created, and it will just able to make the communication with that topic in the SNS. Next, here, first of all, we have the message controller. So this controller will get the message from the client. Okay, so this is a client that is going to send a message over the endpoint. So that endpoint is publishing endpoint, and here it will get the message, and this message will be next sent to the SNS topic. So that I'm calling a send message here. So this function is first of all creating the request, and to that request we are sending the message. Okay, I hope this code is pretty simple and clear. And once the message has been published to the topic, that topic will then push that message to all the subscriber, and one of that subscriber is this queue, simple queue. So what we have did in the another service class, that is the message consumer. So here we are listening to that demo queue. So that demo queue will once the message is present inside that queue, this will get that message and it will be consuming that message. Okay, so this is how this same application is acting as both producer and consumer. Okay, I hope this is clear to you. Let me just quickly repeat the flow. So the controller will get the message, sorry, the SNS controller will get the message. It will be sent over here to the topic, and from the topic it will send it to the queue, and that queue is getting listened in the message consumer class, and here we'll get the message finally. Okay, so let me just run this. Okay, so the application has been started successfully on 8080. So here let's send a message. Okay, so this is the first message to SNS. Okay, so we have successfully sent the message and we have got the response, and let's check now. So we have sent the message. So the message was sent over to the topic. From the topic it was sent to the queue, and from the queue we finally got the message over here. So this is the first message to the SNS. I hope you're able to understand this. So if you want to cross check, we can just comment this and we can just rerun the application. So now what will happen in this case, the queue will have the message, but it will not be consumed because there are no services that are polling to that queue. So if I again send a new message, this is the second message to the SNS. Okay, so we have successfully sent it, And this time, as you see, we had this, the message was not yet consumed. So in this case, if we go back to the queue, and if you go to send or receive message, you will see that there is one message that is pending in the queue. If we poll for that message, we will get that. Okay. So this is a message, right? This is the second message to the SNS. So I hope you are able to understand this flow, how it is working. Okay. So now if I go back to the application and just uncomment this and rerun the application, then you will see that the message will get consumed. So it will get consumed only after visibility time is over, right? Now we have got the message. Okay, so now let's next discuss a couple of brief details about the SNS, and then we'll see a real life example where it is used. Okay, so let's discuss a couple of more details regarding SNS. So as we already know, what's an SNS? So it's a push-based broadcast system where the consumers are not polling or pulling the messages, but it is the SNS that is going to push the messages to all the subscribers who are subscribed to a topic. So the process flow will look like producer publishes a message to the topic, and then SNS fans out the messages immediately. So this thing we just now looked in the demo. Next, subscriber types. So we can have different types as we discussed. So in our case, we used SQS queues. So apart from SQS queues, you can also use Lambda function, email, SMS, webhooks, or mobile push notifications. So we'll discuss a real life example regarding mobile push notification next. The purpose, as we all know, this can be used for notify multiple systems instantly, achieve the loose coupling, and core to the event driven designs. So when we want to create an event driven design, then in that case SNS can be used. Next, one of the real world example use case can be order placed action. So once an order is placed for an e-commerce application, multiple systems need to be notified at the same time. So it will trigger the inventory or shipping service, it will trigger the email or invoice generator, and at the same time it will trigger the notifies the analytical platforms, right? Next, it can be also used for the mobile push notifications that we'll discuss next, how it can be integrated. Next, it can also be used for alerting and monitoring the systems, where when we have multiple systems, and let's say if any one of the system has some issue and we want multiple systems to get notified, for that definitely SNS can be used. Then we can have fan out the event processing that we already discussed, and broadcasting the events across environments. So wherever basically we need broadcasting the messages, in that case SNS can be used. And strengths, what are the major strengths it has? That is instant push delivery, that is real-time push we can get with SNS. Next, have massive scalability because it is serverless, everything is managed by AWS, so millions of messages can be sent per second. Then we have multi-subscriber option, we can have multiple subscribers for one topic, and broad integration with AWS service. So this is one of the greatest strength, where we can easily integrate that with multiple AWS services and have the, as I said, it is serverless. So we don't have to maintain anything, AWS will maintain that. Next, there are some limitations that also you should keep in mind. That is, first of all, no message is stored. So once a message is sent to subscriber and if it is down, then that message is lost. So to overcome that, we can go with the SNS SQS pattern, where from SNS, we will first send it to SQS, and SQS will make sure that the message is delivered properly. And if it is not, then we have an option of dead letter queue. So with this pattern, we can overcome this, but by default, the messages are lost if the subscriber is down, and there is no reprocessing or reply. Next, alternative of that is Kafka or Event Bridge. We'll discuss that later. Next, it has at least once delivery. So due to that, sometimes the subscriber might get a duplicate or two messages, same messages. Then in that case, a subscriber should be idempotent, where it should be able to identify two identical messages. Next, the message size limit. So it has a maximum size of 256 KB. If we want some bigger messages, then we can just send the S3 link. That S3 link should have the complete message. So that can be done. Next, ordering is not guaranteed, but if we want that to be guaranteed, then we can go with both FIFO in both SQS and SNS. So that will make sure that ordering is guaranteed. And we have limited filtering capabilities of the messages. So this needs to be explored. You can explore that from your end. We have an filtering option while creating a SNS topic. And next, as we already know, this is a push only model. This does not support the pull based. So I hope these things are clear. Next, let's look at one of the real world example, how SNS can be integrated. Okay, so here let's understand how SNS can be integrated for notification systems that is used by major enterprise applications like Zomato, Blinkit, Uber, right? So how they are able to send millions of notifications every day. So let's understand that. For that, the first thing we need to do is when let's say we have created a mobile application. So when a user registers through our application, we need to make a backend call from that application to our server. And in that backend call, we need to send the device ID of that mobile application, okay, or that mobile basically. So that's a first step we need to do. Either that can be on Android or iOS. So once we have the mobile ID in our backend, so our backend will make a next call to the SNS, okay, for the subscription to that topic. Okay, so first of all, here we will have different topics. So let's say the first topic we have is the notification. So this notification topic we are using to send a mass notification to all the users. Okay, so in this for this topic, all the users will be subscribed of my application. Now let's say similarly I have another topic like Delhi. So what does this do? This is a location based topic where I want to send the notifications only to those users who are from Delhi. Okay, so I will subscribe to this topic for all those users who are from Delhi. So here let's take a case of notification topic. So now what we are doing, once our user has registered, we will receive the device ID, and that device ID we will like subscribe, we will send that details to the notification topic. And for this topic, all these device IDs get registered, like they are got subscribed. Now this under this notification topic, we have all the device IDs of our users. Okay, so this will be the first step. Now the next step is when we want to send a notification. So when we want to send a notification, what we'll do, we will not make these 1 million calls from our backend server. We'll just make one call. Like I want to just send a notification of 50% discount on all the products. So this notification, I will send one call. I will make a one call to this notification topic. I'll just make one call, and this topic will now internally make this 1 million requests to the FCM or APNS. So what is FCM? Here FCM stands for Firebase Cloud Messaging. That's for Android or from Google, and APNS is nothing but Apple Notification System. Okay, so these are the two services that are needed to be used to send the notification to Android and iOS devices. So without this FCM and APNS, we cannot send the notifications to Android and iOS applications. So because of that, now this SNS will internally make the calls, 1 million calls to this FCM or APNS, and then FCM and APNS on the basis of device ID will send the notifications to all the devices of the users. So I hope you got the flow here. So why we are not directly making a call to the FCM or APNS from backend server? Because here we need to make 1 million loops. So we need to run a for loop that will run 1 million times, and that's a very highly performance incentive and that can break in between, right? That will break the whole system. So that's the reason we are delegating that process to the SNS. So here we just need to make one call to the SNS topic, and under that topic, all the device IDs will be registered. So now SNS will make sure or take care of calling to FCM or APNS for sending the notifications. I hope you are able to understand. And this is how overall notification system works in almost all the enterprise applications. Okay, so here either we can use SNS or there are many other services can be used, but mostly this is the best service that you can use, and it's highly cost effective, right? Because here the cost incurred for sending 1 million notifications is just for that one request. So the one request which our backend server will make to the SNS to send the notification. So only for that one push notification we need to pay. For other 1 million requests which the SNS will do, we will not have to pay, because that will be taken care by SNS, and that's the same for FCM and APNS also. But if we are sending the emails or SMS kinds of notifications, then definitely every SMS or every email will be costed. But for these kind of notifications, it will not cost anything, and it will be almost at zero cost. Okay, so I hope you are able to understand this the role of SNS in this architecture, where it is helping us to publish the notifications to all our users on the basis of device ID. And next, let's look at the another service that can be used for the asynchronous communication.